Hey class, sorry I can't be there today, but today we are going to look at the discriminant, which is part of the quadratic formula, and we are going to use that to solve our quadratic equations. So just a reminder, we are looking at solving equations that are in the form of ax squared plus bx plus c equals to 0. So we want to make sure our quadratic equation is equal to 0. And then remember that a, b, and c are the coefficients in front of the x squared, the x, and then the constant at the end. And then we're going to look at the quadratic formula, but we're going to talk about the quadratic formula, the discriminant first. So just a reminder, the quadratic formula is x equals negative b plus or minus the square root. B squared minus 4ac all over 2a. And then the discriminant is specifically the part under the square root. So the b squared minus 4ac part, the part that's under the square root, is called the discriminant. And we're going to use the discriminant to help us figure out how many answers it has and what those answers are going to look like. So if the b squared minus 4ac part is bigger than 0, then we know that the has two real solutions, two x-intercepts. Because when you take the square root of some number that's bigger than 0, like the square root of 81, we know that we're going to get like 9 and negative 9, because 9 squared is 81 and negative 9 is also 81. So we get two of those answers, and then the quadratic formula has the plus or minus built into it. So you get positive 9 and negative 9. So two real solutions. So on our graph, that would look like this. Let's say we're counting by threes. So we got negative 9 and positive 9 are our x-intercepts. So our discriminant is bigger than 0. So a positive number bigger than 0. We're going to have two real solutions, which are two x-intercepts on our graph. Now, when we have the discriminant equals 0, then that means you're going to get plus or minus the square root of 0. But the square root of 0 is just 0, so you get plus or minus 0. So if the discriminant, the number under the square root, is 0, you're only going to get one x-intercept because the square root of 0 is 0. So then it's going to come down to whatever is in front. And you might recognize that negative b over 2a. We've been looking at that. That's how we graph our parabola. That's our axis of symmetry. So we get the negative b over 2a and we get a 0. That means our x-intercept is going to be our one solution. So we're going to have one real solution on the x-axis. And then if we have a discriminant, so the number under the square root is less than 0, which means it's going to be a negative number. You get the square root of something negative, like negative 5, you're going to have no real solutions because the square root of a negative number is not a real solution. So no solutions. You can't take the square root of a negative number. And if you try to put the square root of a negative number, like in your calculator, you do the square root of negative 5, it will tell you that there's no solutions, no non-real answers. So no solutions means that there's no x-intercepts. That doesn't mean that we can't still have a parabola. It just means that the parabola is not going to cross on that x-axis. So one solution, two solutions, or no solutions. And we can tell that by our discriminant. So let's do a couple examples. Okay, so we are going to use the quadratic formula to solve for x. And we're going to start by finding the discriminant because that's going to be our first step of solving the quadratic formula. So when we find the discriminant, we are just looking for the b squared minus 4ac part. So in this example, our a is the number in front of the x squared for this one, which would be 1. B is our number in front of the x, which will be negative 11, and c is 10. So plugging into the discriminant, you want to put a parenthesis where each of your substituting values are going to be. So then you're plugging in for B, that's going to go right here. Then you're plugging in for A, you're going to put the A right here, and then you're plugging in C right here. So that's going to be negative 11 squared minus 4 times 1 times 10. And then we can put that right into our calculator just like we see it. So we're in a parenthesis, negative 11. Make sure that you close, make sure you put the right number in and close the parenthesis before you square it. Minus 4, and then you put parentheses 1, parentheses 10. So the calculator knows that if you just do parentheses that it's times. So that's 4 times 1 times 10. So you're going to get 81. So the discriminant is equal to 81. And we know that is greater than 0. So we are going to have 2 real solutions, which means that our graph, I got to move that, is going to cross the x-axis 2 times. So I know that this one opens up since A was positive, so we're going to have 2 x-intercepts, 2 real solutions. Okay, so now the quadratic formula, I'm going to write that up on top again. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we know that we found the discriminant already. That was this part, so we can plug the 81 in for the discriminant. So we write the quadratic formula just one more time. We're going to have negative b plus or minus the square root b squared minus 4ac all over 2a. So we're going to plug in. We're going to have to plug in for b plus or minus the square root. We're going to have to plug in for the discriminant, and then you're going to have to plug in for a. So the negative b over 2a part, you're going to plug in b there. And then we're plugging in a here, and then our discriminant's going to go here. So we know that our b was negative 11 again, and that our discriminant, the b squared minus 4ac, was 81, and then a is 1. So we're going to have negative 11 is going to make positive 11, plus or minus the square root of 81 over 2. So let's do the square root of 81 first. The square root of 81 is 9. So then we can split this up. We're going to have 11 plus 9 over 2. And then we're also going to have 11 minus 9 over 2. So the plus or minus right here is giving us these 2 answers. We have one for the plus, and we have another answer when we go in the minus direction. So the square root of 81 was 9, and then we substituted that out for a 9. So then 11 plus 9 is 20 divided by 2, which will be 10. So you're going to add first and then divide. 11 minus 9 is 2. 2 divided by 2 is 1. So we end up getting 2 answers here. We're going to go back up and write this here. X equals 1 and x equals 10. So our 2 answers are 1 and 10. So our x-intercepts would have actually been at like 1 and 10, and our graph would have been over here instead. But that was just a quick sketch. So those are our 2 answers for that one. Okay, I kind of ended up taking up a lot of space there, so we might have to move number 2 down here a little bit. So I think I'm going to block this off just so I know that that all goes with number 1. So I have a little bit of space for number 2, but not much. So number 2, so first of all, we need to make sure that we have our equation, our ax squared plus bx plus c equal to 0. So we'll notice here we have it equal to negative 4. So we will have to add 4 to both sides so that we get it equal to 0. Now on the other side, the 9 has an x squared and the 12 has an x. So we cannot add the 4 to either of those. So it is just going to go at the end of the equation. So we're going to have plus 4. So that means our A is 9, our B is 12, and our C is positive 4, not negative 4. The first thing we're going to do is find that discriminant. I'm just going to shorten it up a little bit. which again is going to be that b squared minus 4ac. So b and then ac. So then remembering that we are going to be plugging in the 9 for the a. B is 12, so when we do b squared, we're going to have a 12 squared. And then in this one, c is 4, so we're going to be plugging in a c of 4 there. So we're going to have 12 for b squared minus 4 times 9 times 4. And then we'll use the calculator to plug that in. Similar to what we did last time, parenthesis 12 squared minus 4 times 9 times 4. And we get discriminant equals 0. So discriminant equals 0. That means when we have the quadratic formula and we plug back in, we're going to end up having 0 under the square root, which means that we are going to have just one. This is equal to 0, so we are going to have one real solution. All right, I am out of space, so I think that I am going to bring that equation down here. The 9x squared plus 12x plus 4 equals 0, and finish solving it down here. So remember, quadratic formula is going to be x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. Okay, so we're going to have x equals negative. We're going to have to plug in for b. We know that the discriminant, the part that is under the square root, is going to be that 0 that we found up top. The b squared minus 4ac equals 0. Then it's all over 2 times a. So out front, we're going to have to plug in our b value, which remember from our original equation was that 12. And then we're going to have to plug in our a value again on bottom, which is the 9. So we're going to have the negative b, it's going to be negative 12, plus or minus the square root of 0 over 2 times 9. So the square root of 0 is 0, so you're going to have negative 12 plus or minus 0 over 2 times 9 is 18. So you're going to get negative 12 plus 0 over 18, and then negative 12 minus 0 over 18. But negative 12 plus 0 and negative 12 minus 0 are the same thing. So you're going to just get negative 12 over 18, which we can simplify by dividing both by 6. So negative 12 divided by 6 is negative 2. 18 divided by 6 is 3. So we're going to get x equals negative 2/3 for that one. Negative 2/3 for our solution. If you plugged that into your calculator, you're going to get negative 0.6 repeating. So if you did the decimal answer, where did I put that calculator? Negative 12 divided by 18, know that that is negative 2/3. Remember, you can do alpha y equals to enter in the fraction, and if you do it this way, then the calculator will reduce it for you. And I would prefer the reduced fraction instead of the decimal since it repeats forever. Otherwise, you have to put the little line above it. All right. We're going to do it one more time. I apologize. This is taking up so much space. Hopefully, you guys are still with me. All right, so similar start. We have to get it equal to 0 again to start. So you're going to have to add that 5 over. Plus 5. We're just going to add it to the end since it can't be combined with an x squared or an x. And then we got a is 1, b is negative 2, and c is 5. We're going to find the discriminant first by doing b squared minus 4ac. So b squared minus 4 times a times c. So we're going to be plugging in 1 for the a. We're going to be plugging in negative 2 for the b. And we're going to be plugging in c, 5 for the c. So we're going to have negative 2 squared minus 4 times 1 times 5. And we can go ahead and plug that into our calculator. So we're going to do parentheses, negative 2. Make sure you close that parentheses, then square it. Then minus 4, parentheses 1, parentheses 5. So we're going to end up getting a discriminant, which is negative 16. Now this is the part that goes under the square root, the b squared minus 4ac part in the quadratic formula. And since it's negative and you can't take the square root of negative numbers, this means that it has no solutions. So even if you were to go on and do negative b plus or minus the square root all over 2a, you're going to end up having a negative 16 here. B is going to be 2 and a was 1. So you're going to get 2 plus or minus the square root of negative 16 over 2. But if you try to do the square root of negative 16, you're going to get an error, which should tell you again that there is no solutions. So the answer to this question is just no solutions. There are no answers for this, which means like on your parabola, it does not cross the x-axis at all. So no solutions. Okay. Give it a try. I want you to complete the 8.7a worksheet. Make sure to check your work as you go and do your best. We'll practice it again when I get back. Thank you. Whoop.